Hello, everybody. Good evening. Good morning to people based in America. Um, Welcome to the episode number 3 of Thank God It's Thursday. For real, thank God it's Thursday because we just have one more day to the weekend. Joining me is Gaurav, our product manager, who is leading our efforts to make cloud security intelligent, automated, and trust-driven. Right? Today we are covering the most fundamental yet the most underutilized aspect of cloud security, that is threat modeling. So Gaurav, how are you feeling today?
How about you?
I'm good. I'm good. Is everything alright? I couldn't hear you properly.
Am I audible?
Yeah,
Any
yeah.
issues?
Now, yeah, yeah. Let's go.
Okay.
Gaurav, let's start with basics, right? What is threat modeling? Can you dumb it down for me?
Yeah, sure. We have been seeing this threat modeling quite a lot in our design discussions, or probably when we hear the word secure by design. And
Yeah.
threat modeling is kind of, as the name suggests, it's a kind of an approach to detect threats in your architecture using certain techniques and approach or maybe outlook. So we have frameworks for that. We have kind of you know um, external facing versus internal architecture that we have to understand, and based on that we have to uh, probably decipher what kind of security issues an architecture can withhold. So that's threat modeling.
Okay. So, what is the difference between a traditional vulnerability scanning and threat modeling?
So usually what happens is security is always an afterthought, and we have been discussing about that quite a lot, and it's still prevalent in today's day and age. Usually everybody builds the software at a rapid pace. With the advent of AI, it's now more easy to do the vibe coding and get the software platform of your need. But one thing that is often overlooked is security. So while we have been hearing about vulnerability prioritization, EPSS, CVSS scoring, KEV, all of those which helps to prioritize the vulnerabilities that are getting impacted, or maybe that are surfacing for the application, which we do that while building the application, and post deployment also we try to test that. But threat modeling is kind of a proactive approach where it talks about before even spending any development effort. Let's try to understand what essentially the threat can be there from what we are architecting, and then spending the development effort on building the product platform. So it's basically more proactive as opposed to reactive security. Like you can do pen testing once the application is deployed, but threat modeling calls upon detecting or maybe analyzing or discussing the issues that can happen while inception of the software architecture that we are building.
So, can we say it the way that it is more of understanding about potential attack vectors before being exploited?
Yes. So before even being developed, I would say,
Mm-hmm.
identifying that and trying to have a mitigation or just like kind of best practices or design principles in place before even you start to build the software. And once you have the best design security design principles in mind, with that, if you build the software, it will have lesser vulnerabilities to deal with.
Yeah, that makes sense. Um, what is the like? Could you tell me, explain me the ABs of threat modeling from A to Z? What happens? What is the process like?
So usually you have your architecture that is under the
Mm-hmm.
scrutiny. You identify the boundaries, the external facing, the internal facing, the entire data flow diagram. And based on that, then you're trying to understand what are the threat vectors, what are the kind of attacks surfaces where the sensitive informations are kept. And then you try to run it through the frameworks like Stride and FAIR to understand the threat that can be there, and what could be the cost implication to that. And then accordingly you are if you follow the design principles, security design principles, then you can also uh, validate or and as well as you can mitigate those issues well in advance, and that also saves a lot of cost and efforts in the process, because you do not have to manage different builds to fix critical issues. You are proactively taking security as one of the pillars while you're building the
Right.
software, and you're validating that continuously, because software keeps changing, new features keeps getting added. So you do that process in a continuous fashion.
So, are you saying my takeaway from this is you are saying Stride is a framework, that it is a structured way to turn threats into measurable risks? Is that what you're saying?
Yes, it will identify what kind of issues are there, and
Mm-hmm.
where is more like assessment on the implication of those attacks, like
Okay.
whether it is a cost implication and how much of that is, how often it is likely to occur. And stride is more like understanding the threat vectors itself.
Yeah. Shall we go to next slide?
Please, yes.
So yeah.
Yeah,
Um,
go on, please.
would you take a deep down? Would you give us a deep down explanation of what actually stride means, Gaurav? You covered
Sure.
fair. Yeah.
Yes. So stride and fair, it's basically, let's try to understand what they are. One is kind of what are the issues or threat actors, like I said, and fair is more like an assessment of what kind of attack or damage it can cause, what kind of loss to the infrastructure or company that it can cause, and how likely it is to happen. So when we talk about stride, the full form of that is basically the initials of all these bulleted points that are mentioned: spoofing, tempering, repudiation, information disclosure, denial of service, elevation of privilege. Spoofing is usually like when you're trying to impersonate any kind of services or users. And this is something that we need to understand. Usually that happens when there are weak authentications and overprivileged accesses. Entering of data is more like a malicious, uh, you know, way to tamper the data and have that, maybe placed in the database, maybe data at rest or data in motion. If you're tampering with that, and that's also something which is very easily done with OS top 10 issues like cross-site scripting, SQL injection. Repudiation is more like your there is an event that happened, and there is no auditing or logging of that.
Right.
So there is no way to backtrack who
Yeah.
caused that destructive action. Information disclosure is more like a sensitive issue is there, sensitive data is there because of unrestricted access. Somebody got that, and somebody is trying to expose that. Um, so there is a risk there. Denial of service. If somebody hijacks a particular microservices, or maybe denies the service to a legitimate users, that's what denial of service means. An elevation of privilege, it's more like if a microservices or maybe some kind of API have higher permission, then it can also do some, in case of API part reversal, and in case of microservices, it can also access other microservices to gain more privilege and can do more damage. So that's more
Right.
like how different threat vectors can be there on your infrastructure, on your architecture, basically. And if we cater to these points and have a kind of a secure by design approach, we can actually mitigate a lot of issues that otherwise we would see later in the software development lifecycle, and that will incur both cost and the time effort. Fair is more like now, okay, I understand the issue, but what kind of damage it can cause? So that is loss magnitude. So what is the cost implication to the organization? Loss event frequency is more like how likely it is to happen that particular issue. So it's kind of measuring the issue, risk based on the threat vectors that we have discovered in Stride. So it's kind of you can say complementing to each other and understanding the entire picture of the threats and the damage that it can cause.
Gaurav, could you walk us through an example of how a typical issue might people might encounter in cloud native architecture?
Okay, so let's go and let's take some example and let's discuss first with the stride. So usually there what happens is if you talk about like principle of least privilege, a particular service account or maybe services can have access to all the tables and all operations. So they might be leveraged by some kind of attack vectors if somebody gains the access to that service account or the API, then they will be able to have the unrestricted access to those tables and also perform any action like read, delete, write, and all of those. So we need to follow the principle of least privilege, and that's basically elevation of privilege, the risk that is associated with that. Usually also what happens in defense in depth is or maybe when we talk about you know the secure design principles, what happens is, let's suppose an application is there and it is trying to have kind of a uh, somebody is trying to gain access to that particular application. Now if you have defense in depth approach, you have multiple layers of security. Like for example, firewall could be layer 1, and
Right.
if there is a client side input validation, that could be layer 2
Yeah.
defense, and if it is a server side input sanitization, that could be layer 3, and then intrusion detection, some kind of anomaly detection, could be layer 4. So you can have defense in depth to also ensure that those scenarios don't happen. If an API is able to breach a particular API, or if a threat vector, if a outside actor is able to breach one of the APIs, then also it should be restricted and it should not be able to do more damage to the application. The other thing is like path traversal. So usually what happens is, once you gain the access to one particular API, you usually try to enter a lot of your, you can say, extensions to that URL, and we call it subdomain. But what happens is, if there is no default deny or save by default, right? Or deny by default, then what happens is they will be able to gain access to those APIs, which otherwise would have been dormant. So we need to also ensure that those are denied by default. So there are
Yeah.
these kind of issues that can happen, but there are definitely more that I can
Yeah.
talk about.
Gaurav, when you're talking about layers, I got this doubt. How do threads differ from layer to layer? Let's say IAC misconfigurations to lateral movement at runtime. Could you explain us?
So yes, so Stride is all about looking at issues, while layered approach to security is more like your security design principles. Now, when you look at any kind of architecture, you need to understand the outside in perspective, and also once they are inside the system, what are the different approaches that they can take. They can do path traversal, they can do a cross-site scripting, they can do SQLi injection. I'm taking a lot of names, but essentially what it means is whatever they can do to use the permission set that they have and the information that they have, if they can use that to exfiltrate some sensitive information, we need to understand that. So layered approach towards security is more like a design principle, security design principle. If we adopt that, then we will be safe in those scenarios even if there is a breach. So it's more like a design principle rather than a stride quality. Stride basically asks us to look at architecture from the perspective of these kind of issues: spoofing, tempering, repudiation, information disclosure. It's more like a generic statements on what we need to look at. But when we talk about applying these to every microservices, every API, every databases that are there, information, sensitive information, then it has real meaning. And that's where you try to do defense in depth. You apply these principles at all those different components, which we will also see in coming slides.
Just a quick note to viewers, everybody, please drop your doubts. If you have, Gaurav would be more than happy to answer. Is that right, Gaurav?
Yes, of course.
Yeah.
Yes. Yeah. So this is more like a cloud native architecture. and that is what I was trying to talk about when we talk about defense in depth. We need to apply least permissive posture in all of these, you can say, components of the architecture. When you talk about the application layer, it's more like you're trying your microservices. If they are having weak authentication, um, they can be exploited. So we need to ensure on that aspect. We have a server side, client side validation. On top of that, intrusion detection and all of that. Front end layer, basically, when you talk about SQLi injection and others, what happens is if I gain the access to an API, and if I'm able to put the malicious payload to the API and it writes to the database, that's where the issue is. There are several examples of what all issues can happen, but I'm just giving you one. Data layer, let's suppose your database is there and it has public exposed configurations, or it has access to a lot of service accounts and APIs. Then those are also issues. Identity and secrets, it's basically when developer code secrets into any kind of code repo, a public code repo, then we call it secret sprawl, and that's an issue. And also, like, sometimes what happens is secrets are not rotated. Like, ideally it should be rotated every 90 days, and most often than not, secrets are also sometimes like long lived. That's also an issue. Secrets should also always be short lived and rotated. And third party APIs is basically when you are allowing these APIs to access the application, then you need to have a repudiation or kind of auditing and logging to all these accesses that they can do. They can end up deleting something and you not knowing what happened and who did it. So we need to hold them accountable and have those repudiation as one of the examples in exploiting third party APIs if somebody does that. So this is one of the examples in each of these components of the architecture, but there are definitely more that we can talk about.
Yeah, that's a very insightful one.
So this is what data, you can say, look like a kind of a mm, approach to what all, where all data traverses, what all data layer look like when you talk about the architecture. So you can do that all those analysis with the stride, and then you can get these exposures understanding as well.
So
We can move to the next.
does it give visibility to how it can be exploited in sequence, like
Yes,
full
yes,
form
it does.
attack path? Okay.
Yes, it does. It can give you kind of, so it can give you the threat actors and the exploits. You need to understand your architecture. You need to tell what are the data layers and how they communicate to each other. And then you need to map those issues to the framework, to the architecture, basically. It will not give you a flow diagram per se, but it will give you definitely the issues that are there.
Understood. So, Gaurav, once you identified these issues, what are the next steps? What are the actionable steps a company or a person can take to control these?
Yeah. So security design principle, if I quickly list that, principle of least privilege, and that applies to service accounts and the users, RBAC, like all those aspects. And then you have defense in depth. That is very important. At each component that we saw, you need to have different level of authentication. Uh, no one service account should have access to different, you can say, um, permissioning. Like, for example, if service account one is responsible for deploy, for build, and for all of these, then it will be a single point of failure. We need to have different permissions tools, or then we can divide that risk. We also need to have that is usually called separation of duties. We also need to have kind of a minimize attack surface, which means that sometimes what happens is there are redundant APIs, there are unused ports, there are some code features that are not in use. We need to always keep on sanitizing that. We also need to ensure that there is a complete authorization to, and also scrutiny to anybody accessing the sensitive information. So, for example, if an API is having access to a sensitive information, then it should be logged and then it should be cached. It should not be like the cached data is available for too long.
Right.
Otherwise, it falls into the risk of the service account, or maybe the user is revoked the access but can still access the data.
Um,
So some
can
of
you
those.
explain us how AccuKnox and how do we map these threat models to concrete security policies or controls?
Yeah, so what we have done with customers is we have analyzed all these threat vectors, and we have given them a plan to how to remediate that. We have also AI assisted remediation to help in that process, and this is secure by design, where we advocate this in a mutually agreed upon cadence call, and provide them with all the insights like what is the threat vectors, how it looks like, and what could be the impact to your organization. And we deal it with criticality. So basically, if something is publicly exposed, we handle that first, as opposed to something that is internal communication or authentication issue that we can see, something like that. And then we work with the customers to ensure that these are done. So it's basically, you can say, a joint at the hip kind of a you know principle that we use with customer. They help us, we help them to achieve the secure by design principle in their architecture.
Gaurav, you mentioned AI remediation. So, how does AI work in aspect of threat modeling, right?
So we need to understand that threat modeling is kind of, you can say, an approach where you need to apply the security best practices, and you need to ensure that you put every scrutiny that is there to it from an understanding perspective, and run it through the frameworks like Stride by Microsoft and others to get the context. But additionally, you can also have your own experience and thinking applied to the architecture and do more with that. Where it helps with the remediation with AI is we can quickly tell them what you can immediately do to remediate that particular issue, and that they can get that kind of a context from the platform itself. So we help them to achieve that remediation uh, with the AI assisted um, steps.
That's awesome.
Yeah.
So, what are trust zones?
Sorry.
What are trust zones and
Yeah.
actors?
Sure, sure. So trust zones, we need to understand that from the aspect of, you can say, internal and external. Okay. So when we talk about internet zone, it is usually the untrusted, the public facing, the externally, you can say, resources trying to access the software. The VPC network zone is more like a controlled, you can say, private network that is with customer environment, where we need to also ensure that whatever the resources are there in the VPC are only having the internal access, and principle of least privilege followed, and they should not be exposed. Application zone, it's more like where your microservices talk to each other, and there is a service mesh to fetch the data and retrieve the data from the microservices. And database zone is where your sensitive information lies. So that's the most restricted and audited kind of, you can say, resource that we need to look at from the threat modeling perspective. And then there can be different threat actors to it. It can be internal, it can be external, it can be developer. So how developer, if somebody is external, everybody would understand. Anybody is trying to do DDoS, XYZ. Malicious insider could be any compromised employees or spoofed employees who is trying, somebody is trying to impersonate and trying to gain the access. Developer is more like, any developer should not have an access to vault or secrets, because there is no need for that. They should be directly, they should be just coding, and the separation of duties come also there. The service accounts is, and they are unused, so we need to also account for that. And then you also have API third party that we also need to put into scrutiny, because those also can affect the overall application, and we need to also account for those.
Right. Gaurav, all this sounds so powerful and vast. Is it difficult to maintain this? Is there any automation we can do?
So Automation from the perspective of findings lifecycle management, we do that usually. Like if something is very critical, we auto ticket it, we auto alert the customer. And if something is, let's suppose, maybe external facing, we also can have some kind of remediation step to that. But it's more like when you talk about secure by design and adopting that as the very first stage of software development, which is like design discussion. There we need to follow this process, and this I'm calling this as a process because this is something as a, you can say, a kind of a process that you ensure that is there to have the security by design implemented and incorporated while you are developing these softwares itself. It's not the afterthought, it's something that we take into consideration while building the software, before even building the software. And we try to mitigate the common known issues with that. So I would say that automation is there from the findings lifecycle management, but when it comes to adopting this as a process, it's something that the companies have to go through individually.
Got it.
Yep, I think we have talked about some of these, so we can skip that. Otherwise, yeah, I can also talk about that.
Yeah.
So usually what happens is our premise is this. It's trial and fair analysis we can do for the customers, but at the same time, we also have other modules that can help customers in detecting the issues, even if something percolated to the production instances. We have runtime risk detection, runtime security, and also AI security on top of that. So although like this is, you can say that we are taking every measures to ensure that there is a zero trust architecture in place using threat modeling. But at the same time, we need to also ensure that there are other modules at runtime so that we have the visibility, policy governance, and kind of a risk assessment um, on the application which is customer facing. And it's kind of a combination of the both which AccuKnox can deliver.
Gaurav, listening all of this makes me wonder. See, I'm the least person. It makes me wonder how all can fit into DevSecOps pipeline.
Yeah, so we adopt the, you can say, threat modeling as an experience, as a process change before even DevSecOps starts. And then DevSecOps is something that Equinox can definitely support with, which is something that we can automate directly in the pipeline. And it can have various stages check like SAST, DAST, IAC, container scan, secret scan. And then finally, once you deploy these applications into the production, then their runtime risk detections like KSPM and runtime security based on zero trust can come to the picture. So it's like you can say that proactively detecting issues in the architecture itself using threat modeling and having a secure by design architecture, then automating the DevSecOps pipeline to ensure that the shift left and detect early vulnerability aspects can come to the picture. And then finally, once the application is facing the customers and deployed in production, then we can have a runtime risk detections and also runtime zero trust protection at the production clusters. So it's basically every step of the way we can have that implemented.
Got it. Glad I asked that. So yeah, we have a minute left, Gaurav. Let's open the floor for questions.
Sure.
Yeah. Uh, Viewers, feel free to drop your questions in the chat. We'll pick a few before we wrap up. Gaurav, do you have any closing remarks?
No, I think like what I was saying from the last statement was it's a complementary solutions to have threat modeling, DevSecOps principle, and the runtime security, all that in parallel to ensure a safe and secure software development lifecycle chain. And this is something we have to adopt as a process. So usually what happens is DevSecOps is the first thing that companies start with, which is only fair. They want to see some clients and customers wins before talking about the security. They are in the early journey, but then threat modeling can come to the picture, and finally with the runtime security as the last piece to ensure that they have a safe, fail-safe kind of approach towards the security. So proactive, the most proactive is your threat modeling. Then it could be the DevSecOps shift left and detect early, and then it could be the runtime detection at the production. So we do all of that, and we help customers in all of those aspects.
Good. I guess we can close it up. Have a great
Sure.
day, everyone. Good night.
Thank you. Have a good one.